Is it good?
Yeah.
Good morning, everybody. Welcome back to lecture number 19. Today we will revisit example 7 because there is some confusion about it, okay? Now, what did I tell you? What did I tell you? أنا قلت لكم الريتنج حقت السنجل فيز 3 phase transformer هي coil to coil. You agree with me? You agree with me this line? This group, you agree with me? It's coil to coil. Whether it is connected as delta to delta, Y to Y. So if I have my coils like that, delta to delta, or Y to Y, or Y to delta, or delta to Y, always I have A equal N1 over N2. N1, N2. N1, N2. Here coil to coil, coil to coil. فايش معناتها هذه 13.8 على 240? I haven't connected the transformer yet. But I know that A is 13.8 kilo over 240. But we have a transmission line here, 3 phase, that has line to line. So now do you remember we love line to line? We cannot say we love line to line in the transformer because line to line in the transformer depends on the connection. Instead we love coil to coil. Okay? Because transformers, they have 2 ways of connection. So what is this delta? It is 13.8 kilovolts. You agree with me? Now I'm connecting these cables to the bushing of the 3-phase transformer. We call them bushing. Then they enter the 3-phase transformer, which is a box, okay? 3-phase transformer, let's make it simple. Let's say it's a 3-core. And I'm telling you, it is connected how to connect it like this? No. It's hard. Let's pretend that this transformer is for some reason, if I'm telling you 13.8 appeared, you don't see, come and walk and see. 13.8 the coil matches a line to line. So now that's me equivalent of saying, so one side of the transformer is connected to a 3-phase 13.8 transmission line. This is equivalent of what? Equivalent of saying it is delta. The other side, he is telling you there is 3-phase load of voltage 415.7. 415.7. Why? Because we love line to line. But in transformers we love coil to coil. So this is telling me if I'm connecting it to the transformer, it has to be a Y. ليش؟ لأن هنا عندي 240, هنا 240, هنا 415. 240 times square root of 3 equals 415.7 volts. So this is equivalent. يعني لما قال لك connected to transmission line of 415.7 وانت تشوف هنا 240 الكويل, I know it is Y. Get it? So if I'm telling you the line is 13.8 times square root of 3, then I know the line, transmission line at the high side is what? Y. But because they match, it's delta. This is one important information. And don't ask me in the middle of the test, oh, is it delta or y? Don't ask me, because I'm not going to answer this question. تفهمها من الأرقام. It's not my job to tell you. Easy, صح? Another confusion. That's why I repeated this example. Here I have 10 kVA. Here I have 9 kVA. Both of them are three-phase quantities because we love three-phase. Is this correct or not correct? That is wrong. Because I didn't read the question. Let's read the question. Each single phase is rated at 10 kVA. ايش معناته؟ معناته ان for الترانسفورمر XFRM the three-phase rated power is what? 3 times 10, which is 30 kVA. The S one phase is 10 kVA. Okay, let's read the statement. حقة اللود. The other side of the XFRM is connected to three-phase residential load of this power factor lagging. 9 kVA. Is 9 kVA single phase or three phase?
Three phase.
Three phase. Right. He's saying. So S of the load is 9 kVA. So what is S of the load? One phase.
Three.
So if I'm connecting the XFRM to three-phase load of 9, how much capacity I have remaining to process?
1 kVA.
Hmm?
1.
21.
Wrong. You're right. 21. I still have bandwidth of 21 kVA. So this answers the question. Remember, if I tell you don't connect a refrigerator, try efficiency. If we reduce the S, the efficiency goes down. He's only exploring this residential side. And that's the problem of power system. Power systems, they need to optimize everything, maximize utilization of their transformers. Get it? So don't ever confuse the 10 and the 9. Both are three-phase in this example. This is single phase times 330. This is 9 for three-phase. I have room of 21. Another thing, the power factor lagging. I already have the S's. Why he is giving me the power factor information? Because if I want to calculate the real power, or if I want to get the phase angles. But if we do phase angles, we need to go back to the slides. If I have Y to Y or delta to delta, I don't have phase angles. Go to the slides. Here nothing talks about phase angle. Here they don't talk. But if I have Y to delta, the secondary voltage lags the primary voltage by 30 degrees. إيش معناتها؟ معناتها if I have here voltage of 0 degrees, the voltage here AB will be something at 30 degrees. If I have delta to Y, if I have a voltage here to be at 0 degrees, the AB here, because we love line to line at the end, yeah, we love coil to coil, but once we connect them, we still love line to line. This will be what? This will be minus 30 degrees. Is it required in this course? No. Okay? The only thing you need to know is this sentence, because it's in the slides, and this sentence. Just remember, whenever there is delta, there is a lag of 30 degrees. Okay? That is why example 7 does not talk about He only asks about the magnitude of line current. He didn't ask about the angle because it's hard. You can't do it now. It's not in your interest if you learn how to do it today. That's not proper. Once you master the magnitude analysis, then next, in the senior year, you can pick any power course and they will teach you. Okay, 462, 463. Clear about it? So in three-phase transformers, we will not have angles because they are hard. Okay? For single phase, we still have angles. For circuit 1, circuit 2, circuit 3, these things, we have angles.
دكتور احيانا صار عندي confusion يعني احيانا لما نيجي في السؤال يدينا الريتد هذا اللي هي 13.8 كي في 214 فولت هذا يعتبر حق الكويل
ايوه هذا يقول لك ان الريشيو between N1 and N2 N1 and N2 N1 N2 N1 N2 no matter what you do it is 8.
طب هل هذا يعتبر الفولتج هذا لاين تو لاين ولا كويل تو كويل؟
No, let's say, okay, say with me. In transmission lines, we love line to line. In loads, distribution loads, we love line to line. Say it with me.
In distribution loads, we love line to line.
But in transformers, before the connections, say with me.
Before the
We love coil to coil. Once we make the connection,
once we make the connection,
we go back to line to line.
go back to
Does it make sense?
يعني قبل الكونكشن
قبل الكونكشن يعني قبل ما تحل المسألة هذا اللي معناه. أنت عندك ترانسفورمر كذا في الهواء موجود ما هو مشبوك.
اوكي.
We love coil to coil. You do your analysis عليه. Once you connect it.
خلاص صار لاين تو.
لأن أنت you care about the terminals.
صح صح.
إحنا الحين أنا هذا عندي not connected. Let's see this is delta. This is not connected. I love coil to coil. The moment I make a connection, I look where line to line. If the connection can Y, let's apply it before the connection. And let me transform. I love coil to coil. After the connection, oh, I love line to line. Now I have the square root of 3. I have square root of 3. Because there are 4 ways to connect the transformers. How many ways to connect the transformers? 4. So, get it? Now, let's go back. Yes, please.
عندي سؤالين، أول شيء الكويل تو كويل وين بالضبط مكان الفولتج؟ الأزرق
على الأزرق. مو فولتج، الترانسفورمر لما ما هو مشبوك ما في له فولتج. ميت. Life will comes when you connect it to the system, but this is properly it's not the voltage. This is the ratio of number of coils here over the ratio of the number of coils here. That's why we love coil to coil.
طيب دكتور سؤال ثاني، كيف استنتجت الشكل حقها من السؤال؟
استنتجت الشكل حقها من السؤال لأن من السؤال قال لي secondary voltage low voltage should be in Y to provide the lead residential لأن 240 هي عبارة عن 415 على سكوير 3. هنا في السؤال connected to 3 phase load of 415. فأنا عارف إن الكويل 240 فأنا أضربها في سكوير 3 فعرفت إن هذا Y. بينما في الهاي سايد ولا البرايمري ولا الليفت 13.8 دايركتلي على اللاين. اللاين احنا نعرفه we love line to line. فأنا عارف إن هذا لاين تو لاين. فأنا قلت لك 13.8 appeared هنا معناته إنه دلتا. إذا في تشابه دلتا بمجرد الاختلاف it is Y. So we know it's Y we know that. There is a small note. If the primary is connected in Y, what will happen? It's not important for now, but think with me. You have 13.8. 13.8 over the square root of 3 appears on the coil. What will happen معناته ان السكندري بيصير اقل. secondary بيصير اقل. ف one of the benefits of delta connection is you get higher secondary voltage. Delta Y connection. What do they want? We have guests. Let's see. تفضل.
السلام عليكم.
السلام عليكم.
عبد الرحمن مقاطعة. اليوم يوم المعلم يا أستاذ.
الله يعطيكم العافية.
سلام وأنت طيب.
شكرا
يعطيك
شكرا.
ألف عافية.
يعطيكم العافية.
الشباب حابين يقولون شيء اليوم ترى اليوم يومه.
الله يعطيكم العافية. شكرا شكرا. يعطيكم العافية. شكرا. We have good.
مسجلة.
I'm not gonna cut it. He's the one who walked. It's nice gentleman. Thank you for him and the lady who took the picture.
كيف يوم واحد للمعلم؟ كل الايام للمعلم.
I don't care about it.
هذا عشان ترجع فهم رشيد الدكتور. يمكن نقول كذا عشان ترجع فهم رشيد يعني.
They clap, you didn't clap. No formula. Who told you that? Who told? And it's bad, you ruined it more. We have to cut these things. It cannot appear on the YouTube.
بس هذه اللي قبل لا.
Okay. Let me think. I don't know, to be honest. The exam is we haven't decided. Let's wait. The primary is connected to Y. Then the load voltage will be higher. Okay. Now let's do. This is a visualization. 13.8. 13.8. What is here? No, this is 415. What is here? To 70. 415 to 70. 415
to 40.
240 here, 415 here, 240 here. No, 270. 270 here. Is it two? Okay, 240, 415. خلاص معلش. So you see a connection here, red line, delta.
Okay.
This is Y, Y, Y. The lower coils share a cable. And there's cable here, there's cable here, there's cable here. So what did he do? He took VAB because after a connection we go back, we love line to line, VAB over VAB small. So VAB capital or VAB small is VAB is 13.8 over square root of 3 times 240. It's very simple because 13.8 over 415. Here, what did he do? This is a simple single phase circuit. He solved it in front of you. So what is this single phase circuit? So in reality, I'm saying 240 and I'm having a load. This load has S, one phase load, to be what? 9,000 over 3, which is 3K VA. You agree with me? I explained it to you. I'm converting. I'm getting a calculation for a single phase circuit. Why? Because he asks the question, find the magnitude of the line current of the bank.
شو يقصد بقى؟ الريت يعني؟
Now we talk about visualization. Let's go back. Line current اللي هو يمشي هنا. والline current اللي يمشي هو هنا. This is the phase current. This is the phase current على الكويل. So what do you notice? في الواي الline current is equal to the phase current. في الدلتا, no, we have a split here. فالphase current doesn't equal to line current. We explained it last lecture. You remember?
Yes.
So he wants the line currents. To get a line current, I need to draw a single phase circuit. Why do I need to draw a single phase circuit? To get, I know it's 9,000 over 3, but I have 3-phase system. So what is the current per phase? Is 3 kVA over 240. Why 240? Because I'm drawing the single phase equivalent circuit. I'm drawing the single phase equivalent circuit. And you can get the current to be what? 4 amps or 12.5. So what is 12.5? 12.5 is the current that goes through this coil, which is equal to the load current, line current. Line goes to the load. Remember, for a while you get difficulties على الvoltages, صح? But the phase current هو line current. For a delta, the voltages are easy, but you have problems where في الكرنت يصير عندك مشاكل. What is the problem? I told you we only deal with magnitudes. So let me get first the current through N1. هذا N1. So we call it here I1 over I2 equals 1 over A. You agree with me?
Yes.
So what is I1? Is I2, which is 12.5 over A. What is A? 13.8 kilo over 240. If you do the math, this is A. You remember your A? What is A? 13.8 kilo over 240. Which is what? 50?
57.5.
50.7.5. So that's why you get a very small current of 0.2174. If you get bigger current in the higher voltage, there's something wrong. Okay? Remember.
So
When you,
move 13.8 على square root of 3 to 40.
don't confuse yourself. We're still doing coil to coil. Coil to coil. This one is a 25. The coil has a current. Like in a line current here, then we apply your formula. Square root of 3 I line. After you are done, and someone forgot this USB. That's one of the reasons I don't use USB. Somebody forgot. So I line equal to I phase square root of 3. Remember we have angle minus 30, right?
Yeah.
So what is I line? Square root of 3 times 0.2174, which is 0.377 amp. And that is the line current that goes through before distribution حق الدلتا. Get it?
Yes.
If it's not clear, you raise your hand. Not clear? Not clear? Do you have issues with the battery?
No.
What I'm telling you ان هذه المعادلة تعطيك الكرنت اللي يمشي على الكويل. بس لأن دلتا كونكشن بيصير في تفرع على الأحمر وتفرع على الأزرق. اللي بيجي من اللاين بيتفرع بيدخل على السي وبيمشي على الكويل حق الاي. فهذه المعادلة is coil to coil. Coil to coil. Then you will have square root of 3 على اللاين.
وهل هو بيكون نفس اللاين على اللود؟
يعني أنا بعطيك أنت عندك كويل هنا صح؟
إيه.
Because it's delta
بيكون في تفرع واضح.
بيصير هنا في current وبيصير هنا في current. هذا اللاين. يصير في تفرع هنا وتفرع هنا. في الواي كونكشن على طول الفيز هو على اللاين. فاللي 1 over A بس بيعطيك الكويل. فالاي برايمري over I secondary equal 1 over A. هذه المعادلة تعطيك الكرنت اللي على الكويل. بس هو يبغى الكرنت اللي على اللاين يوز الايكويشن I phase times square root of 3.
طيب بالنسبة للسكندري
This is secondary because it's Y for a Y connection phase current equal to line current. الفيز في الحالة هذه كويل.
دكتور لما تسوي انت الضروب في سكر 3 انت ما راح تعرف قيمة الكرنت اللي ماشي تحت.
كيف ما تعرفين؟
يعني انت كأنك قاعد تحاول يعمل فيس تو لاين.
Yes, because هذا phase quantity if it goes here هذا الكويل. أنا أعرف الكويل أبغى أرجع لللاين.
طب والكرنت اللي ماشي تحت
I don't care about it. حيطلع نفس القيمة، حيطلع نفس الكرنت. تفرع متساوي. يعني انت قصدك ليش ما ضربنا في 2 وخلاص؟
لا ليش يعني كارت هذا كيف حتعرف قيمته؟
Because الفيز shifts في عندك phase shift في الانجلز. When you have phase shifts, they are the ones who create square root of 3. Do you remember? Use your calculator. 1 minus 1 angle 120. What was the answer? You remember?
0.6.
1 minus 1 angle 20.
33 angle minus 30.
Hmm?
33 angle.
So angles created square root of 3. So when you do, you cannot say half of the current will go here, half of the current will go here.
هو مو ها حيكون بس.
No, you have angles beyond the scope of this course. But you know this is a phase quantity, this is a line quantity, use the equation, that times square root of 3. In reality, there is a phase difference of 30 degrees between, 120 degrees between these two. I told you if you take 463, we'll explain it to you, I promise. 462 or 463, one of them, I don't know. Get it? الفكرة وما فيها إنه الphase quantity equal to line quantity is square root of 3 times the phase. That's what you need to know. التفرع هذا فيه له phase difference in angle. Because the phase difference in angle, you can't say it's half. Get it?
Okay.
Now it's clear? And then we're done with this problem. Another concept that I want to talk about. What is this concept? The per unit system. Let's say Aramco Stadium has a substation. What is Aramco Stadium substation? What was the number?
13.8 kilovolt to 240.
No.
No,
It was 115 kilovolts to 13.8.
دكتور الويز I think it 13.3. Yes.
They love this now. They love certain numbers. But it's not always. Now let's say the KVPM substation. Maybe it's old, 69 to 13.8. Then we have inside transformer 13.8 to 240. Then you have my transformer 240 to 110. So there is always transformations. Primary to secondary. Okay, primary to secondary, secondary to primary. So a key problem in analyzing power system is there is a large number of transformers. It would be very difficult to continually referring impedances to different sides of transformers. Does it make sense? This one is rated at 5,000, this one is rated at 9,000 MVA. When you develop models for a big system, there should be a unified approach. So the problem can be easily eliminated by normalization. Well, normalization is actual quantity over a certain base. And what's the unit? Is per unit. إذا كان volt per the units of volts. إذا كان ohms per the unit of ohms. إذا كان MVA per the unit of MVA. So in general, actual quantity over the base would give you the per unit. So if I give you the per unit, what's the actual quantity? You take the per unit times the base. Get it, Yam?
Yes.
Now, let's say S base, usually one of the very common numbers is 1000 MVA for a base. Or let's use 100. Maybe 100 is. Let's say S base. Is S base 3 phase or single phase?
Single phase.
من الكونتكست حق اللي هنا. S base, do you think it's 3 phase or a single phase?
3 phase.
3 phase.
Who said single phase? You're saying S base is single phase. Who else?
No, 3 phase.
3 phase.
Who says S base is single phase? Raise your hand. Okay. Logically, he divided by 3, so I understand this is the 3 phase, this is the single phase. So if I'm telling you S base is 100 MVA, what is S 1 phase for base? 100 على 3. Let's say I have V base of خلينا ناخذ Aramco substation 13.8 السكندري side. Is this line to line or phase? Line to line.
كيف عرفنا؟
Industry. إذا ما تكلم line to line اللي هي coil to coil. بس احنا ما ندري Aramco substation هل هي دلتا واي ترانسفور ما يدنوا ما بنوها باقي يبنون.
كذا لاين تو لاين هو.
Okay?
زي كذا تقول لاين تو لاين.
Line to line. But if you want to know details inside, you would use coil to coil. What is I base? He used S for one phase divided by V base, which is 10 over 3 MVA over 13.8 kilovolts. What is 100 over 3 over 13.8? What is this number? Calculators, please. Don't do the mega, don't do the kilo. I'll teach you how to do it later.
2.4.
2.4. What's the second digit? 2. Mega over kilo.
كي
Kilo. V over V.
وين؟
Cancel. Amps. Get it? We saved 1 minute in the test by not having thousands.
كبيرة الرقم مرة.
That's okay. It's a fictitious system. Fake system. You want to use 115? Let's use 115. Let's use 115. Of course, Aramco substation will not be 100 megawatt. Let's use 115 kilo. What's the answer? كيلو amps, صح؟ 290 amps. Now, what is Z base? It's V base over I base. I'm using another equation. What is this number? 115 kilo over 0.9 kilo. Kilo مع kilo cancel. What is 115 over 0.29?
396.51.
Ohm. Can you use the other equation? V base, one phase square over S, one phase base. $115 square. Kilo square is what? Mega. Megavolt over megavolt square over 100 over 3 MVA. What's the answer? Should be the same. 396 ohm. There's a third equation. Try it. For S base, 3 phase. Now he said V phase, V line to line. It doesn't matter because if you use V line to line or I line to line, you stick with it. You'll get an impedance line to line. If you use phase quantity, voltage phase quantity, you'll get Z phase quantity. But you have to be consistent, okay? Usually in transformers, in real life, what they do in the papers, they will draw a transformer. They will put 3 lines. Then they will tell you 115 over 13.8. They don't even write the units in the drawings. They don't have time. Then they will tell you R 1%, X 7%. What does it mean?
tolerance.
You have to think as an engineer. I know it's a 3-phase transformer. I know it's a step down of 115 kVA because in the system you will know when you read the drawing it's 115 kilo or 115 volts. Not only that, the R is 1%. It means the R combined of the circuit 1 or circuit 2 or circuit 3.
One.
Wrong.
Two.
Circuit 1 you have to split them.
Two.
Circuit 2 or circuit 3. Both. It means R equivalent referred usually to the primary, usually. They either write RP or XP, or they write XRS or XS, depending on the engineer who made the drawing. But you need to think, oh, he put P, it means refer to primary. Is 1% of per unit. Sometimes they put percent, sometimes they put per unit. It means 0.01 times Z base. And then you get the number. For an X equivalent primary, they will say 7%. Sometimes they put the per unit. It means 0.07 times Z base. And now per unit saved me time. I just put 1%, 7%. I don't need to put the values. Get it, Omar? Get it?
Yes.
That's why when we solve this example, so before we go, for voltages, if the reference values are chosen to be the rated values or per unit values would be 1.05%, 0.95%. If you see a voltage 0.6, there is something wrong. Because most voltages should be around this range. This allows a direct and immediate perception of the system voltage. I tell you, this is 1.05 per unit, this one is 1 per unit, this one is 0.9 per unit. If I see a system 0.7 per unit, means there is a voltage collapse. Or if I see 1.3 per unit, it means there is over voltage. I don't need to know what is the voltage level here, 115, or here 13.8. So per unit system is the one used in industry. So if you want to create a control room, the control room will not show to you all the information. They would love to see everything in per unit. So per unit is the way to go, okay? Let's say this example. Read this statement. 50 kVA, 13.8 kilovolts to 208, delta to Y, distribution XFRM, has resistance 1%, reactance 7%. Quick question. Is this a single phase or three phase?
Three phase.
Why did you know it's three phase?
That's into what?
Because he mentioned the delta. Is there a single phase with delta? So this is it S base or S one phase base?
This one is good.
Correct. That is S base because it's three phase. So this is S base equals 50 kVA. So what is R equivalent? Let's say refer to primary. What is the transformer phase impedance referred to high voltage or primary? Is 1% times Z base. What is Z base? He said refer everything to primary. 50 over 3. No, what's the equation?
B squared over.
Okay. B squared is 115 square kilo square over 50 over 3 MVA. What's the Z base? Z base will be 11,426. Multiply this by 1%, multiply it by 7%, you should get the impedance. We'll continue next lecture.
First, I'll see 115 or 15.
Oh, I got confused. The high side is 13.8. 13.8 square kilo square. Kilo square is mega. Mega will cancel with mega. So 13.8 square over 50 over 3. This is Z base, which is 11,420 تضربها في 1% يعطيك الآر تضربها في 7% يعطيك الإكس. Get it? Anything not clear? Next lecture we'll start with part B, okay? Homework is due Sunday. Quiz 3, October 21st. Fake quiz before that. Major October 22nd. You can go, Ishabah. I want to keep you long. Is it still running?
Victor, I sent for you the photos. I sent for you the photos of my